Hello friends, in the seventh question of JEE Main Physics paper, code A, they are telling from a solid sphere of mass m and radius r, a spherical portion of radius r by 2 is removed. Okay, initially we have a solid sphere, now r by 2 radius small sphere spherical portion is removed. So once it is removed, after that we have a cavity here. Cavity, empty space. And then we have to find gravitational potential at the center of cavity here. We have to find gravitational potential at center of cavity. Okay, so before solving it, this is not a direct question. If you want to solve directly, then you must know some direct formula. Okay, so let me start with very basic how to proceed solving this question. What are the concepts of gravitation is required in this? The concept is definitely of gravitational potential. How to find gravitational potential? Okay, so let me start with how potential changes as we move away from any mass object. Suppose I have a mass object m at a distance r. What is gravitational potential at a distance r? Minus gm by r. And what is gravitational potential at infinite distance? 0. This is by convention. So it means as I am moving from this mass object away from each other, away from it, so gravitational potential is increasing from negative value to 0. So suppose if small displacement is dr away from this mass object, so this dr is positive, the small change in potential dv should also be positive, because we know potential is increasing, so dv is change, so that is positive. So I can write dv by dr is equal to, this should be a positive value, and we know that the potential gradient is equal to gravitational field. Gravitational field magnitude is gm by r square. So this is the basic formula. The variation of potential with distance r is given by dv by dr is equal to gm by r square. Now let us find out potential of a solid sphere at any point located at some distance small r inside the solid sphere. Suppose the solid sphere has mass m and radius r. It is a solid sphere. I want potential here. So I will write dv by dr if I move very small displacement dr away from the center towards the surface. So this should be equal to g by r square, radius of this sphere, because field here is only due to this portion of sphere. So this is g by r square into m. Now what will be the m for this, only this portion? What will be the m? So that will be equal to m by r cube into small r cube. So this is gm by r cube into r. So I can write dv is equal to gm by r cube into r dr. At the center small r is 0 and potential is say Vc. and at any distance r, potential is say v. So I can write v minus vc is equal to gm by r cube. Now if r dr integration is r square by 2. If you put the limits 0 to r, then I will get r square by 2. Now suppose I want to find potential at the center. So Vc is V minus Gm r square by 2r cube. We can consider that other point is located at the surface. So I can write Vc is equal to potential at the surface, which is minus Gm by r minus 2 minus Gm by 2r cube into r square. So this is minus 3 by 2 Gm by r. So I got potential at the center is minus 3 by 2 Gm by r. We know potential at the surface is minus Gm by r. Getting? Now let us continue with our question. From the solid sphere, I have removed a small spherical portion of radius r by 2. So in this region I have a cavity, nothing is there, and the remaining region is full of solid material. I can assume that initially I have a full sphere of positive mass density, and in this region I have kept a sphere of radius r by 2 of negative mass density. So this is negative mass and full sphere is positive. So when positive mass combines with negative mass of equal magnitude, we have ultimately nothing. So this region is empty. So what is the potential at this point due to full sphere? Suppose this point is P. So at point P, potential due to full sphere will be